Okay, let's get started. Welcome to our third C-Roads Antwerp-Helmond seminar. Please note that this session is being recorded for the benefit of those who couldn't attend today but would like to view it later. Today we are focusing on smart traffic lights. First, Gwynne van Kouwen from Tractable will give us an overview of our C-Roads project, and she will explain how we have been exploring CITS and light prioritization. Afterwards, Wannes de Smet from B-Mobile will share some real-life examples and use cases. Next, Johan Hellemans from Unix Traffic will get into the technical details of how smart traffic lights actually works. We suggest that you note any questions you may have during the presentation in the meeting chat. We will have a Q&A session at the end where these questions can be answered. I now give the floor to Gwynne.
Yes, thank you, Marleen. I'm indeed here to give you a short introduction to the C-Roads Antwerp-Helmond project. My name is Gwynne van Kouwen. I work at Tractable Engineering, and we are indeed the overall project coordinator of this project. Can we go to the next slide, please? So our C-Roads Antwerp-Helmond project is part of a larger C-Roads partnership, which is a European initiative to link and align all CITS deployments across Europe. 50 European cities are already involved in this partnership that started with the CITS rollout in urban areas. And at the same time, 20,000 kilometers of European roads have been equipped with short-range CITS, and 100,000 kilometers of European roads are covered by long-range CITS services. The next slide, please. Yes, thank you. So the goal of the C-Roads platform, as I said, is to link all the CITS deployments that are happening across Europe. At the same time, in the platform, there's also work being done to develop, share, and publish common technical specifications for CITS. At the same time, the platform also plans intensive cross-testing to verify interoperability between service providers, but also between member states. And lastly, they're working on developing a system test to check common communication profiles with a focus on the hybrid communication mix, so a combination of ETSI, ITS-G5, and also operational cellular networks. So our project is part of this, and we started in November of 2022, and the project is running until actually this month, so we're finishing up right now. And our consortium consists of 9 Flemish and Dutch partners, as seen here on the slide. So our project includes the 2 cities that are also in the name, of course, Antwerp in Flanders and Helmond in the Netherlands, as well as the TEN-T network connecting those 2 cities. The goals of our project are, first of all, to deploy combined Day 1 and Day 1.5 CITS services in both Antwerp and Helmond, and as I said, also on the TEN-T network in between. Then we've also done some cross-border and interoperability tests of the services between those 2 cities, and we're currently working on the evaluation of the services on functional aspects, so if everything works correctly, but also on user acceptance and their experience and impact assessment. And lastly, we are developing scalability and implementation strategies for the different services that we piloted in the project. So we started in November of 2022, and then in the spring of this year, we started with the pilots in both cities, which were ended in the summer. And then the results were made available last month, and we're currently then finishing up the project. Within the project, we have 3 different categories of pilots. So the first one is CITS and ADAS, or Advanced Driving Assistance Systems, which includes intelligent speed assistance, which was covered in the webinar last week, and also real-time traffic information through the mobile phone application of Flitsmeister. The second category is CITS and UVA, or Urban Vehicle Access Regulations, where we have 5 different use cases. And the last category is CITS and Urban Mobility Services, which includes truck buffering, park and ride information, and traffic light priority for trucks and bicycles, which is the focus of the webinar today. So first of all, why it was important for us to work on traffic light priority. The City of Antwerp and Nantes are also involved in our projects, and they had some important reasons for being interested in this use case. For the City of Antwerp, specifically for the bikes, that is to improve the experience for the cyclists at traffic lights by shortening their waiting times for the green light, which would then enable the modal shift, and also would increase safety by reducing red light negation. And for trucks, the idea was to shorten the waiting times at specific intersections to nudge truck drivers to take preferred freight routes, and also to shorten the idling times in the cities, which would then result in less emissions. And then for Lantis, they want to make biking more attractive, more comfortable, and also faster. And more specifically, to limit frustration and time loss at lights for bikes. And their main questions in our project were, first of all, if the technology works, and if so, how the bicyclists do experience this technology, and if it can be easily adapted. And with that being said, I will give the word to Wannes to get more in depth on this topic. Thank you.
All right, thank you, Gwine. So I'm Wannes Smet from Be Mobile, and I'd like to share some insights with you on Be Mobile and our role within the project. So Be Mobile, for those among you that don't know, we are a company established for more than 15 years and active in the traffic information and traffic services field. Specifically in this pilot, we have deployed and implemented some elements of our cooperative traffic offering. So we've been active with our CITS platform in the EU since 2017, and we focus on being cooperative with everyone, using well-established international standards such as DATEX2, TNITS for speed information, of course, the ETSI standards, which provide the backbone then of the C-Roads standards as well. So as mentioned, we comply as much as we can with the C-Roads standards. That's not to say that sometimes there might be 1 or 2 elements that really don't fit well into the C-Roads standards, or where we can contribute them to the C-Roads standards so they can evolve, and then we can achieve compliance again. So our main goal of our CITS platform is to exchange messages and information from roadside infrastructure and road users with each other with an end-to-end latency of 1 second. So it really provides a scalable platform to exchange information, exchange alerts and warnings to each other as soon as possibly can. And currently we are supporting the largest CITS rollout in the world, at least that we know of, in the Netherlands and in Flanders, which is in Belgium. So with that, we have quite some expertise in the value chain to position ourselves in the CITS value chain. So you could consider 4 categories of parties involved. On the most left-hand side, you have the roadside infrastructure. This is where UNEX in this partnership focuses on. This is not something where we are present in. Then you have, in most deployments, you have a facility to exchange information with all parties concerned. So this would be the interchange part and enhancement of information that is provided within the ecosystem. This is something that we provide in the Flemish CITS deployment that's called Mobilidata. Then, of course, we started our CITS offering in the Netherlands with the Talking Traffic partnership, where we are a service provider providing the link between the centrally available information and then the end user applications, which come last, of which Flitsmeister, our driving companion app, is the prime example and is the most popular app used in the Netherlands. But of course, we have several others, not to mention Sway, which we will touch upon later in the presentation. So specifically, what can we do with traffic lights, or specifically the intelligent traffic lights? Well, we can proactively coordinate with them for different groups of users. So we can coordinate with them for the standard motorized traffic, where your regular passenger cars, your motorcycles, and so on and so forth. We can do specific coordination with them for the active road users, cyclists and pedestrians, and also for public transport. Then we also have several use cases specifically relating to priority. So whereas coordination would be better informing the traffic light so that they can better optimize the signal phase, planning priority is the specific alteration of the signal phase scheme to allow one or more road users to pass through more quickly. So the most the canonical example of this use case is, of course, allowing priority for emergency and rescue services, such as ambulance, fire trucks, and so on and so forth. It's well established that these should be able to pass across intersection as soon as possible. But then there are also use cases that we can apply where we allow a convoy of vehicle or cyclists under certain conditions to pass through the traffic light in one group. This is also a certain form of priority. You might not necessarily get a green light quicker, but you can pass through in one convoy. Then trucks as well can get priority for themselves under certain conditions. And then lastly, we can also provide signal phase optimization for cyclists depending on the weather, so that they can get longer green or more frequent green when the weather is bad. So on the case of smart traffic lights, well, there's not going to be a lot of priority or optimization without these lights. Luckily, in Flanders, the Mobilidata program of Agentschap Wegen en Verkeer provided the central backbone of the interchange and also started deployment of the traffic lights in Flanders. And this allowed us in this project to use that infrastructure as well to connect the intelligent traffic lights that were deployed in the Lantis and Antwerp regional locations to that central backbone, so we can have one interface where we can interchange and connect with those traffic lights as well. So let's dive into one of the use cases, specifically traffic light optimization for cyclists. So the idea is, with our Sway application, you would simply activate the application and drive your normal routes, your normal daily route, going from work to home and vice versa, or dropping off the kids and so on and so forth. And then Sway would do two things. So next slide, Marlene, if you please. It has two functionalities. The first one is to provide you feedback on the time to green. It can also provide feedback on the time to red, and it does so visually. So this is what's seen here in the pictures, but this is not a required aspect of the app. You don't need to have it visibly mounted on your bike. It can also be just in your pocket, and then there will be specific notification sounds that tell you it's now 15 seconds still green, 5 seconds it's green light. So you can just listen to the sounds, and we can also provide some vibrations, vibration patterns, to make sure that every possibility that you can experience information from the traffic light you can get through the app. And what this does in the background as well, if you opt into it, you will be sending anonymous positions from yourself with the intersection controller which you are present nearby, so that the traffic light controller can digitally see you and can better plan and optimize its signal phase planning to allow for better passage. So this is the things that can happen with Sway the first time you activate the app. The second element of Sway is a specific coordination in function of the route you commonly cycle. So for instance, let's say you have your daily commute from home to work. Sway will recognize after a certain period that you will always be cycling the same route. It will recognize that and then determine a set of common routes internally. And with those routes, we can go a step further and specifically notify the traffic light not only of your position, but of the time you will arrive until the stop line and the connection, so the direction you will take across the intersection. So this is what you can see here in the screenshots. The first screenshot tells you that our service provider backend has notified the intersection controller that there's a cyclist arriving in X amount of seconds, and he or she will be going in this direction. And because it is a bidirectional communication that we have with the traffic lights, they can then reply to the request, and this will be presented to the end user in the form, and you will get a confirmation that the traffic light is optimizing for you. The very concrete use case of this is pressing the button on the light itself is no longer necessary. So you will actually see when the request has been accepted by the intersection controller, the light will activate to give you a confirmation in the physical realm that the lights, that you have been seen by the intersection controller. So instead of having to drive up to the light itself, stop, push the button and wait, we will now notify the traffic light well in advance that you are arriving. So there's no more need to push the button, and the traffic light can do a better job of optimization, the signal phase planning for you. So then we also have the use case for trucks. So we have partnered in a project with a company called Food Savers, and we provided them with our Drukmeister application. And so what this allows them to do is, based on the functional requirements that have been put forward by the city of Antwerp, of course, they can request under certain conditions, specific timeframes, they can request a certain amount of priority. So this is the great thing about the standards and technology, is there's a great number of parameters that can be tweaked, tuned by the road operator to select a specific amount of priority for a certain target group. So for instance, a truck on specific conditions can request or will get X amount of priority, another type of truck, another amount of priority. What does this look like for the end users? Well, requesting of priority is not open to everyone, of course, because if everyone gets priority, no one gets priority. So when the city of Antwerp or the road operator in general allows it, we provide a request flow directly in the app so that people can register themselves like, okay, I'm allowed to get a certain amount of priority, can request it through the app. And then when that is granted, they will see a visual confirmation within the app that the priority functionality is active. And specifically then, as it relates to the interaction with the traffic lights, on the top right corner, you can see the screens of the time to green information as was available within Sway as well, and then a notification that priority has been granted. So this way, the driver gets a confirmation that priority has been granted, but of course the road operator and back office people for the trucking company also can get access to this information and see whether how many trucks have passed, did they request priority, and if so, were those priority requests granted. So to dive a bit more into the details, how does it work? So what's common for both applications is to work at all or to work as best as they can to need to determine a route. In the case of Sway, we don't ask users to plan a route each time as it's meant for your daily commute. So Sway by itself will try and determine your common route profile and determine all the common routes you commonly take. Whereas Truckmeister, you specifically are requested to plan a route yourself, or this route can be inserted through the fleet management system. So these are the both steps. So this is a real world example of what a route determined by Sway might look like. Of course, there is no black magic, so to speak. We have to work with the location capabilities that are present in common smartphones. And depending on the location, depending on the smartphone model, these may be very usable or a bit more hard to parse. So on this image, you can now see a route that was cycled a number of times from east to west. And you can see it mostly tracks along the bicycle path, but you see this one weird line there in front of the intersection. So this is essentially this is the route that is determined within the Sway application, is then transmitted to the mobile backend, and our backend has then to figure out, okay, this is then the route that's been determined. What are the connections? What are the maneuvers that the cyclist is going to take across the intersection? And then figure out, okay, this is the request that I have to make to the intersection controller to request priority or cooperate with the intersection controller. So on the next slide, we will see this happen in real time. Maureen, if you just click once and start yes. So on the left-hand side, the blue moving dot is me actually cycling. And what we can see here, there's been a route established that passes through those two intersection controllers and those two intersections. For each position update, we determine the estimated time of arrival to the stop line. So when that drops below 1.5 minutes, we will start the interaction with the traffic light itself. So what you can see here, this is a screen capture of our backend, our platform, where we can real-time track our users on our acceptance environment for debugging purposes. So what you can see now, we're approaching the 1.5 minute mark. Perhaps I should have driven a bit more quickly, but here we go. So now you can see the triggered has become active, and this specifically then relates to the creation of a priority request, as it's called. So here we can see on the, it's a request for a normal bicycle. We update the ETA, which we then share with the traffic light controller itself. And then response status is actually the response we get from the traffic light controller present at the intersection. And here it's processing. So either processing or granted means that the request has been validated and that the intersection controller is now working to allow passage for that bicycle. So this is what we expect to see. This is what has been tested in this project as well, both at the Landis and Stad Antwerpen location. So of course that concludes our end to request priority and request interaction with the intersection. But that doesn't mean that it's all that easy to do on this intersection as well. And so to give you a bit more insight on how this works from the intersection controller itself, I would now like to pass the word on to Unix to explain how this works in their traffic light controllers.
Okay, thank you, Hannes, for the explanation so far. Good morning, my name is Johan Hellemans. I'm responsible for CITS within Unix Traffic. At Unix, we provide intelligent traffic solutions. We operate and maintain more than 1,500 traffic controllers in Flanders, Brussels, and also Wallonia. But we also provide traffic management centrals, parking guiding systems, tunnels, and waterway monitoring, and much more. Today, we're going to elaborate more on CITS and the use case priority. So CITS, it means it provides a useful interaction between, on one side, the infrastructure, like for example, the traffic lights, and on the other side, we have the road users like cars, public transport, emergency vehicles, but also, of course, the active road users like pedestrians, cyclists. CITS relies on a traffic management central or an ecosystem like Mobilidata, the ecosystem that is used in this project. Its role is to collect, process, and share information from different data sources to the road users that can make use of it. So the information, for example, is coming from our traffic lights. The traffic lights provide the time to green for all the different signals, for all the different road users. The individual timing of the traffic light is shared to the platform. And so applications like the Sway application can make use of this information if it identifies a user going up to the traffic light. And it will know at which traffic light it should get green or red. It can already provide this information upfront to the user. But of course, also other information like in the other use cases, accidents on the road can be shared, also broadcasted to a lot of road users. So it's all about being cooperative, sharing the information we have to as many different parties. That's it. On the next slide, please. Thanks. For the traffic light prioritization use case, in this case specific for the active road users and for the trucks, what we did in this project is we made the connection with the Mobilidata ecosystem that is there, and by making this connection we can get the information from Sway, the priority request from Truckmeister and Sway, but we can also provide them with information from the traffic lights. So we make the connection with the intelligent traffic lights and also the older traffic lights. We can make this connection and all data is shared, both the time to green information as well as the priority requests. And also priority request is not just one-side communication, it's a two-way communication. We can provide feedback if we will allow this priority request. Maybe if a road user is a pedestrian is asking for a priority and there's an ambulance, we can also indicate like it's not going to happen. You have to wait a bit, there's an ambulance passing. In this case, we work specifically with the traffic controllers of Landis and Stad Antwerp, and we enabled them for CITS. So this means that there is a communication module, 4G communication module inside of the traffic controller, and it's made ETSI compatible. ETSI is the European protocol to allow priority requests based on predefined messages. Also on the traffic actuation program, so that's the actual program inside of the traffic controller that decides how long it will stay green, when it's going to the next phase, if it should extend or shorten certain stages. Here we made changes. So first of all, that we can share spot information. Spot is the signal phase and timing information. it's quite easy to share the current state of the traffic lights, but it's more difficult to share the information of the upcoming green times. If we say it's gonna take 10 seconds that you still have green, but then we get a priority demand, it can become a bit difficult. So we try to generate the spot information based on all the information we have at that moment in the traffic light. Sometimes we need to update the spot information a couple of seconds later, but also protocol allows for it every single second. We can provide updates of the signal phase and timing for the complete intersection. And of course, the priority handling. Typically in the past, there was bus priority was a good use case with physical loops in the ground, but now things become more complex, but also more handy for traffic engineering. With SRM, we have much more priority levels. So what we did is we created a CITS toolbox for traffic engineering, so that if they have an intersection which should be enabled for CITS, they can have all the tools in their hands to create a well-balanced traffic actuation program. The next slide. Yes. So for a traffic engineer, the full ETSI information is available. This means fine-grained priority levels ranging from, for example, road users, pedestrians, cyclists. We can imagine that, for example, when it rains, you want to give cyclists a bit more priority. We have buses and trams. We have trucks eventually. If at certain intersections, this is a priority to have trucks move more fluent. And then on the high priority, we have ambulances and fire trucks or military vehicles that can demand priority. So we have much more fine-grained priority levels than before. And what's also very important, we get an estimated time of arrival of each of those priority requests. So we can get this information much more upfront. For example, an ambulance, there's no problem in getting this information that is going to reach an intersection more than 200 meters or even further away. We can get this information even from neighboring intersections. So that makes it much more easy to already do some upfront changes to how the signal plan will develop in the next couple of seconds. We also get the updates of the ETA, which means that if the ambulance diverts or is getting stuck in traffic, we actually will see this happening, and we can interact and try to react on that as it happens. While in the past, for example, if you take the use case of the public transport with a physical loop, this costs a lot of money to have a physical loop in the ground, and so typically there was only one loop. Of course, it's a problem when the bus passes this loop, and then it still makes a stop to allow people to enter or leave the vehicle. Then, of course, it's not good for the traffic light. It cannot really take care very well of the bus. Also, when the bus is already in a traffic jam, going towards the intersection, and it did not yet hit the physical loop in the ground, we don't even know that there's a bus coming and is already being delayed in the traffic jam. With CITS, we get the position updates much earlier, and continuously we can get updates, so we really know where those vehicles are and how to change the signal plan for allowing a fluent passing of the vehicle. Also in the ETSI information, in the priority request, we get a lot of other info if they are available. But for example, for platooning use cases where we have a group of cyclists, for example, we can provide specific use cases because now at least we have this information in CITS. As stated, the early detection, it allows for emergency use cases to clear the conflict area. That's also something, thanks to CITS, the intersection can better support and reflect the reality. In the past, an ambulance would drive with its lights and its sound on, and it would maybe drive through the red lights. Now, already up front, we can clear the conflict area. That's actually the middle of the intersection where you could hit another vehicle if it's still there. That's what we call the conflict area. We could clear it already by making sure the other directions are given red up front, and then we can allow for a safe passage of the ambulance. It also allows for better balance, because we know that there is a bus coming. We might wait a bit before we allow pedestrians to cross, and so we can do more to optimize and have less impact on other road users. The tools we have is also extending and shortening green times, making jumps in the signal plan, changing or skipping phase orders. So we provide a lot of possibilities, and every single second when we decide what we're going to do, we have all the latest information thanks to CITS. In general, much more different types of road users can get priority, or at least an early detection, and also the information about the time to green. We can provide priority or detection to any road user. We provide the tools to the operator, but it's up to the government to decide what they want to do. And this can be very specific for different intersections. Depending on the city goals, they can be tailored for each intersection. And they can also change during time. For example, during school hours, you might want to set priority a bit different than during rush hours, for example. If we now take a look at the complete chain, so we have our cyclists and trucks on the left. They can use the app, like the Sway app or the Truckmeister app provided by B-Mobile. And there, the geographic coordinates are continuously followed up, like one has explained, and all this information is entered into the Mobilidata core, which is provided by Flanders as the ecosystem for CITS in Flanders. We connect to that Mobilidata core by our Unix CITS cloud, and we talk the protocols, European standard protocols, in order to share this information to the intersections that are connected. Also, we try to do our best to stay within this 1 second rule to get the updates really fast in both ways. And then we can actually provide this information to the traffic controller, which can have optimized signal plans. In these use cases, we not only detect the cyclists, but we also give them some kind of priority. Also for the trucks in this use case, as they are tests, we do give a certain level of priority. In real life, of course, this is up to the government or the owners of the traffic lights, the road operators, to decide what levels of priority they want to give and at what time. Okay, next slide. This gives an overview of the 3 different locations. So we have an intersection of Lantis near the Oosterweel, where there's a lot of works going on, and yeah, a lot of cyclists are passing there to go to their work, and from the going back to Antwerp. And then we have 2 intersections in Antwerp, one for cyclists as well, and one for specifically, as one has explained, for the Truckmeister, to allow fluent passage of trucks. Next slide. These are some images we took. So as you can see, you don't have to push the button anymore. There's a small label to indicate that instead of pushing the button, you should download the Sway application, and then if you activate it, you should be detected early, and depending on the rest of the traffic, you should get priority. We're evaluating right now, and we definitely see benefits for the people that are using the app. Next slide. That's from the other direction. And then there's a last slide. Okay. Also with CITS, we get a lot of information from the traffic controller and also from the rest of the system. The CITS messages contain a lot of information that can be used for traffic engineering and for further optimizations of the infrastructure. KPIs like travel times and origin destination matrices can now be easily obtained via CITS. And so what we're doing is we used to have dashboards based on physical loops, based on the old style material in the traffic controllers. Now we're trying to recreate those dashboards with the CITS information, both from long range, so the cellular use cases, as a short range use case where we get information over ITS G5. And we notice definitely that this information is really useful for travel time calculations and to see the impact. We also evaluate, of course, then the use of CITS compared to the traditional technology. Okay. That was it from my side. If you have more questions, you can also leave them in the chat and we will try to answer. But otherwise, we'll continue with the lessons learned.
Right, so a quick few notes on the lessons that we have learned is essentially the standards and protocols are well developed and ready, the implementations are ready. And as we've seen, it's just a matter of installing them on the street side. The applications are ready and they are now ready to be scaled up. With the technology that we now have, we can better support and provide differentiated services and comfort for active road users by giving them certain forms of priority in like in bad weather or in the specific times of day. And this also allows the road operator to get more fine-grained control over how the intersection controller operates and how it can make distinctions between the service it provides to specific types of road users and the priority they might receive, if at all, when approaching the intersection.
Okay.
So yeah, I think then it's now time for the Q&A.
I don't know if there are questions in the chat. Yes. Do all these solutions fit with privacy regulations?
Right. So let's say the good news of working with several governments is there won't be any chance of leaving any privacy stone unturned. We have been working together within the ecosystem to make sure all data is as minimized as possible to still be able to deliver the functions that we would all like to have. And of course, within the apps, the sharing of information with the traffic lights is opt-in. So if you install the app, by default, you will only receive information, you won't be sharing any information. So in terms of security, in terms of privacy, everything has been well tested and well documented to make sure that everything complies with the GDPR standard and requirements.
Still another question. What does the priority means for conflicted bicycle directions? Can it be a minority of cyclists with the app get more green than more cyclists in the other direction that have no app? I think this also for B Mobile. Wannes?
Well, It depends. Is the answer. So that there's not going to be a situation where you only get green with the app and the other cyclists don't get any green. The purpose of the app is to allow the intersection controller to better optimize the signal phase planning for the cyclists. And of course, by being digitally visible well in advance of other cyclists that might be detected through other means or by pushing the button, there might be an advantage there. But there's no specific rule or guideline that says like a connected cyclist weighs more than a non-connected cyclist. It's just by the function of this use case, you might be able to get green quicker, or the intersection controller is able to do more for you than you would not be non-connected or be detected via other means.
This is indeed also a topic in CITS that we try to take care of, that everybody is inclusive, that it's not only people with the apps that get certain priority, but that we also still have the infrastructure available. So that's something that with the different use cases also in mobility data that are being rolled out, that we really try to take care that it's not just the people that have cell phones that you would exclude younger children or older people or people that don't have cell phones. We really try to take care of it. But indeed, it's a question we should keep on asking ourselves regularly, that we don't exclude people unintendedly.
Another question for the Truckmeister. Is there a control mechanism for app use? In other words, can I use the app and have priority as a normal car driver?
Yeah, so essentially, Truckmeister, as it's been used here as a sort of pilot application, has been there's been several agreements made with the company involved that will instruct their drivers on how to use the app properly. In a more large-scale environment, Truckmeister or indeed the whatever app may be used to request priority will usually be linked to the fleet management service. So it will receive a route from the central back office of the company, and through that route it will receive the permission then to request priority. So it won't be that it's just an app that everyone is able to freely use on whatever condition. There will always be a link to the entity that is actually allowed to request priority on a certain conditions. And then of course there are other measurements that we have in our backend. If we see interesting behavior such as a supposed truck driving quicker than trucks are allowed to drive, then some bells and whistles will start sounding at our backend as well, that someone might be doing something not in compliance with the user agreement.
In general, the like freely available apps, they will only serve for detection purposes at intersections. Of course, in this project, we wanted to do more to show that it's possible. But in, for example, the mobility data ecosystem, everybody that really is able to request a priority, they can make use of dedicated apps or other infrastructure like onboard units, but they will need to go through a complete authentication process, and with certificates that are regularly renewed. So this is controlled by the mobile data ecosystem as well.
There's still another question. Thank you for the answers, but I fear that there is a real risk in the long term we will be obliged to give up a part of our privacy if we don't want to be discriminated in green time.
Well, more of a statement than a question, but in essence, the central proposition of the CITS connected services is to better use the existing road infrastructure, right? Is to allow intersection controllers to do a better job of signal phase planning by giving them more information, by making the road more secure, by people that are on the road can share their position with others, specifically if they're on the hard shoulder. So yes, there is a request that you share your position, anonymized as it may be. But we do think the value proposition will be there and is there today to use these appliances to get more safety, comfort, and use the infrastructure better. But as Johan mentioned as well, everyone is taking care not to exclude certain participants, so that everyone, the people that use it might perceive benefits that will usually benefit everyone, also the people not using the app. And then we also always take care not to exclude anyone.
Okay. No more questions? Then I would like to thank Wannes and Johan for the clear explanations. As Wannes mentioned earlier, the technology is ready to be rolled out and deployed to make active road users more visible in traffic and better protected. In our project, we have 2 use cases with light prioritization, for which we are still collecting data. Johan mentioned it already. If you are interested in the results of this part, we would like to invite you to our final seminar on October 24th at 1:30 p.m. Thank you for your presence today, and we hope we will see you on October 24th. Bye.
Bye-bye.
Thank you. Bye.